This is the video for Accelerated Geometry on Section 14-2, Day 1, Solving Radical Equations. Key vocabulary is radical equations. The essential question that we will be answering in this video is how do you solve radical equations both algebraically and graphically? A radical equation contains a variable within a radical. Recall that you can solve quadratic equations by taking the square root of both sides. Radical equations can be solved by raising both sides to a power. So in this first little chart that we have, kind of walks you through the steps of solving radical equations. So step one is always going to be to isolate the radical. So whatever the radical is, your goal is to get this by itself. So as you can see here, the opposite of subtraction is addition, so they added the 2 to the other side. Next it says raise both sides of the equation to the power equal to that of the index of the radical. So if you notice, the index of this radical is 3, so they raised each side to the third power. And lastly, it says simplify and solve. So the cubic root of x cubed is just x, and 2 cubed is 8. Also remember that for a square root that the index of the radical is a 2. So if you see something that looks like this, know that there's a little 2 right there, which means you're going to raise the whole thing to the second power to get rid of that radical. So let's try some examples. So we have 5 plus square root of x plus 1 equals 16. So first step is to isolate the radical by itself, which means I want to get this whole thing by itself. So the opposite of adding 5 is subtracting 5. So I'm going to subtract 5 from both sides to get radical x plus 1 equals 11. Remember, there's an index of 2 here, so to get rid of the radical, I'm going to raise both sides to the second power. So this just leaves me with x plus 1. 11 squared is 121. And lastly, solve for x. So opposite of addition is subtraction. So I get that x is 120. Now, when solving radical equations, you must check your answers because sometimes, even though it says it works here, when you plug it back in, it does not work. So we're going to check over here by plugging this number in for x. So I have 5 plus the square root of 120 plus 1. Does that equal 16? That's the question. So this is 5 plus the square root of 121. Square root of 121 is 11. So does 5 plus 11 equal 16? And the answer is yes. So then I can say that my answer is x equals 120. Let's try another. So the first thing we want to do on this problem is to isolate the radical by itself, which in this case is the cubic root of 5x minus 7. So the operation between these two is a multiplication. So the opposite of multiplication is division. So I'm going to divide both sides by 7. That leaves me with a cubic root of 5x minus 7 equals 27. Oh, I'm sorry, 12. Next, we're going to raise the whole thing to that of the index of the radical. So this is the third. So this gives me 5x minus 7 equals 12 to the third is 1,728. Opposite of subtraction is addition, so I'm going to add 7 to both sides to get me 5x equals 1735. And lastly, the opposite of multiplication is division, so I'm going to divide both sides by 5 to get that x is 347. So before I say that's my answer, I'm going to check it. So I'm going to go back to the original problem. 7 times the cubic root of 5 times 347 minus 7. Does that equal 84? So 7 times the cubic root, 5 times 347 is 1735 minus 7. So that gives me 7 cubic root. 1735 minus 7 is 1728. So this is really 7 times the cubic root of 728 is 12. And 7 times 12 does indeed equal 84. So our answer is indeed x equals 347. Number 3, it looks like the radical is already isolated, so all we can start with is raising it to the index. So since this is the cubic root, we're going to raise it to the third power. So that gives me 3x minus 4 equals 8. Add 4. 3x equals 12. Divide by 3. And if we check it, we have the cubic root of 3 times 4 minus 4. Does that equal 2? So the cubic root of 12 minus 4, that's the cubic root of 8. And the cubic root of 8 is 2, so 2 does equal 2. Let's try another. We have the square root of 7x plus 2 equals 3 times the square root of 3x minus 2. So if you notice in this case, we can't really isolate the one that's on the left at the same time of isolating the one at the right, because there is a multiplication in front of one and not in the other. So on a problem like this, we're just going to go ahead and do the index. So we're going to square this and square this. So the left side squared is just going to give me 7x plus 2. On the right, remember to do both. So we have 3 squared, which is 9. The square root of 3x minus 2 squared is just 3x minus 2. Distribute your 9. Get x on one side and your numbers on the other. So when I do this, I'm going to add the 18 over to the left, so that's going to give me 20, and I'm going to subtract the 7 over to the right, so that's going to be 20x. Divide by 20x, and we find out that x is 1. So when I check it, the square root of 7 times 1 plus 2, does that equal 3 times the square root of 3 times 1 minus 2? So 7 times 1 is 7, and 7 plus 2 is 9, so this is the square root of 9, which is 3. On the right side, we have 3 times the square root. 3 times 1 is 3, minus 2, so this is just 3 square root of 1, which is just 3 times 1, which is 3. So 3 does equal 3. So this is our answer. Example 5, you have 5x plus 7 raised to the 1/3 equals 3. Well, how can I get rid of the exponent of 1/3? Remember that raising something to the 1/3 is the same thing as taking the cubic root of it. So think about what you would do if the problem was written like this. How would you get rid of that? You would have to raise the whole thing to the third power. What you do to one side, you have to do to the other. So now I have on the left is just going to be 5x plus 7. 3 cubed is 27. Subtract 7, you get 5x equals 20. Divide by 5, and x equals 4. So we're going to check that. So we have 5 times 4 plus 7 raised to the 1/3. Does that equal 3? So we have 20 plus 7 raised to the 1/3. So that's 27 raised to the 1/3. Remember, raising to the 1/3 is the same thing as taking the cubic root. So the cubic root of 27 is 3. So 3 does equal 3. Number 6, you have 2x equals 4x plus 8 to the 1/2. So if raising something to 1/3 is taking the cubic root, raising something to 1/2 is taking the square root. So how would you get rid of the square root? You would raise both sides to the second. So on this side, this gives me 4x squared equals 4x plus 8. Now we have an x squared and an x, so I'm going to get it equal to 0. So that gives me 4x squared minus 4x plus 8, minus 8 equals 0. I'm going to try and factor this, so I can factor out a 4. This leaves me with x squared minus x minus 2. Two numbers that multiply to be 2. And add to be negative 1. So we need to multiply to negative 2 and add to be negative 1 would be a negative 2 and a positive 1. So this tells me that x equals 2 and x equals negative 1. But we're going to have to check both of these. First one I'm going to check is x equals 2. So 2 times 2, does that equal 4 times 2 plus 8, all raised to the 1/2? So does 4 equal 8 plus 8 raised to the 1/2? 8 plus 8 is 16, so that's really just 16 to the 1/2, which is the same thing as square root of 16. So 4 does equal 4. So then 2 works. Negative 1. So we're going to check x equals negative 1. We have 2 times negative 1. Does that equal 4 times negative 1 plus 8 raised to the 1/2? So we get negative 2 equals negative 4 plus 8. Negative 2 equals 4. And 4 to the 1/2 is a positive 2. So negative 2 does not equal 2. Therefore, this is an extraneous solution. It is not part of our answer. So our only solution on number 6 is x equals 2. Let's try one more of these. So our goal is to get this part by itself. So the opposite of multiplication is division. So that leaves me with x plus 6 to the 1/2 equals 3. Then we're going to raise everything to the second power to get rid of that exponent. So that gives me x plus 6 equals 9. Subtract 6 and I get x equals 3. And off to the side I'm going to check that. So that's 3 times 3 plus 6 raised to the 1/2. Does that equal 9? So 3 times 9 to the 1/2. Does that equal 9? 9 to the 1/2 is just 3. So 3 times 3, does that equal 9? Yes. So then our answer is x equals 3. Example 8 says you have the square root of negative 3x plus 33 equals 5 minus x. So we're going to get rid of this square root by squaring both sides. So this gives me negative 3x plus 33 equals, off to the side, you may want to FOIL this out twice, or write it out twice and FOIL it together. And you will get 25 minus 10x plus x squared. So I'm going to get this equal to 0. So I'm going to add the 3x over. So negative 10 plus 3x is going to give me negative 7x. 25 minus 33 is going to give me negative 8. And then I have my x squared. And all I'm going to do now is put this in standard form. Are there two numbers that multiply to be negative 8 and add to be negative 7? And that would be x minus 8 and x plus 1. So this tells me that x equals 8 and x equals negative 1. When I go to check, let's check x equals 8 first. So the square root of negative 3 times 8 plus 33, does that equal 5 minus 8? So the square root, negative 24 plus 33, which is going to be the square root of 9. 5 minus 8 is negative 3. The square root of 9 is 3, and 3 does not equal negative 3. So then this is an extraneous solution. It does not work. Let's try negative 1. That's going to be the square root of negative 3 times negative 1 plus 33. Does that equal 5 minus negative 1? So 5 minus negative 1 is just 6. That's going to be 3 plus 33, which is square root of 36. And square root of 36 is equal 6. So 6 equals 6. So negative 1 is my answer. Now, we're going to take the same problem we just worked on example 8, and we're going to solve it graphically. So the first thing you're going to do is you're going to type the left-sided equation into y1, and you're going to type the right-sided equation into y2. I would pause the video for a second and do that so that your graph should come out to look something similar to what I have on my paper. Once you have them graphed in your calculator, you're going to hit your second trace, which brings up your calculate menu, and number 5 should say intersect. And at this point in the game, as long as your first point is on one equation and your second point is on another equation, you should be able to just hit enter, enter, enter. So that's entering 3 times to get the intersection point, which in this case, your screen should look something like this, and it should say that there's an intersection at negative 1, 6. So if the ordered pair is negative 1, 6, your answer would be x equals negative 1, which if you go back to when we solved it algebraically, that is what we got, x equals negative 1. Our other option was x equals 8, but you can clearly see on your graph here, x equals 8, they do not intersect. In fact, one's above the x-axis and the other is below the x-axis. Let's try another one solving graphically. So in your calculator, under y1, type in this left side equation. The right side goes into y2. Your graph should look something like this. However, you notice we have 2 intersection points now. You have a point right here, and you have a point down here. So you're going to have to hit the intersect button, and you're going to scroll up towards this before you hit your enter 3 times. So scroll up towards the top intersection first, then hit your enter 3 times to get that this intersection point is negative 4, 8. Then go back under your second, calculate, intersect, and scroll downwards towards this one, not on it, but close to it, and then hit enter 3 times, and you should get that this one is at 3, 1. So our solutions then would be x equals negative 4 and x equals 3. And again, tomorrow in class, we will go over this to make sure that we can use our graphing calculator.